This is section 5.01 for Unit 5 Notes, Intro to Uncertainty. Today I am, as in you are the student, reviewing factorials, reducing fractions, and reviewing the fundamental counting principle so that I can simplify factorials, convert decimals to a reduced fraction, and apply the fundamental counting principle. I will know I have it when I can solve problems involving converting decimals to fractions, simplifying factorials, and applying the fundamental counting principle. The specific TEKS we're looking at for today's lesson is 8A. Converting fractions to decimals, we've already covered this in a different unit, I believe Unit 1, but we're going to go over it again because we're going to need some of these fundamentals for Unit 5 in the later sections. So, fractions and decimals. As a reminder, fractions and decimals are just different ways of showing the same value. So, for example, 0.5 in decimal form means 1/2 as a fraction, and vice versa. 1/2 as a fraction means 0.5 as a decimal. Okay, so we are going to learn how to change from a decimal to a fraction and reduce it to its simplest form, if possible. First, I'm going to show y'all using the Desmos calculator, and then we'll go through it with the TI-84 calculator. If you're following along using ClassKick, the ClassKick notes that I provided you, there should be a link to the Desmos calculator right here. Or you can Google Desmos calculator and start using it. Make sure it is the EOC version that you're using. So for the Desmos calculator, all we're simply going to do is type a decimal and then click a few buttons and change it to its simplified fraction form, reduced fraction form. So the example it gives us right here on this slide is 0.425. So on the Desmos calculator in line 1, I'm simply going to type in 0.425, and you should see a circle with 2 squares and a line on it. That is the fraction symbol. So simply click it and it'll give you its fraction form. And if it will give it to you in its simplest form, its reduced fraction form, which is 17/40. Likewise, if you want to go from fraction to decimal, simply just type in that fraction, 17 divided by 40, and you'll get its decimal form, 0.425. Okay, and that's it. That's it for Desmos, converting it from decimal to a reduced fraction. Now, to do this using the TI-84, we're going to first type in the decimal. So if you don't have the TI-84, one, it's a physical calculator that you should have been given by K-12, TIVA, whoever it is that sent you the materials for this class. If you don't have this TI-84, I have put it into the course as a download. So simply go to the course content, search up resources, and you should find the TI-84 calculator download there. So now to show y'all using the TI-84, we're going to type in the decimal, 0.425. We're going to press a few buttons, and then it'll turn into its fraction form. So you're simply going to press math, which is right underneath the alpha button, math, and we're going to hit option 1, or you could just hit enter because the 1 is already highlighted. So I'm going to press math and then enter, enter, and there it is. It's reduced fraction form, 17/40. And again, if you want the fraction to decimal, simply just input the fraction into the calculator, 17 divided by 40, and there you have 0.425. Okay, so now if you want to reduce these fractions, it's going to churn them out already. So for example, let's say I have 425 divided by 1000, and I press math enter, enter. It'll reduce it to its lowest form, which is 17 over 40, which is one of the previous decimals that we use right here. So if you have a bigger fraction and you try to change it into a smaller fraction, it will simplify it and give you that answer using this. Same thing with Desmos too. So if you have 425 divided by 1,000 and you press this fraction symbol, it'll give you its reduced fraction form. It won't simply just restate what fraction you have. It'll actually simplify it to its lowest terms for you. So just something to think about when using either one of those calculators. Okay, so now here is you try number 1. I would like for y'all to convert each decimal into a reduced fraction. You can use Desmos, you can use the TI-84, doesn't matter. And then you have the answers right here. So just move the box and check to see if you did everything correctly. When you enter it in ClassKick, by the way, it'll show you whether you got the right answer or not. So if you would like, answer these in ClassKick and then check yourselves using the box right here. So at this moment, go ahead and pause the video and work this problem on your own. Otherwise, I'm going to continue on and show y'all the answers. So I'm going to show y'all the first one using Desmos and TI-84, and then I'm just going to show y'all the answers to the rest because it's pretty much the exact same process for every single one of these. So 0.031, 0.031, change it to its fraction form by clicking the button, and there it is, 31 over 1,000. Oh, did I type in something wrong? Yes, I did. It should be 31 over 1,000. All right, so my bad for the answer choice the answer that I gave y'all there. That should be 31 over 1,000 as your correct answer. Okay. Now showing y'all using the TI-84. Simply put 0.031 math, enter, and it'll give you 31 over 1,000. And so that is your answer for this one. You do the exact same thing with either calculator for these next 4 problems, and you should get 1 over 8, 3 over 100, 7 over 8, and then 1 over 4. And that's it for you try number 1. Factorial. So here's the definition of factorial. The factorial of a non-negative integer, n, is the product of all the positive integers beginning with n and counting backwards to 1. Okay? So the expression n exclamation mark is read as n factorial in math. So this is the technical definition. Now, what does that mean for y'all, the students? So what that means is when calculating a factorial, whatever the n value is, you're going to be counting down until you get to 1. So, for example, 1 factorial. Let me cover some of these and then reveal them as we go. 1 factorial means we're going to start counting from 1 backwards until we get to 1. There's only one number from counting backwards, and that's number 1. And then we're going to multiply all those together. With 2, we're going to start from 2, count backwards, 2, 1, multiply all those together, and then we have 2. From 4, we're going to start counting backwards. So 4, 3, 2, 1. Multiply all of those together, and we get 24. From 6 factorial, we're going to start from 6 and start counting backwards to 1. So we have 6, 5, 4, 3, 2, 1. Multiply all of those together to get 720. Now notice that we're using whole numbers. We can't do this with decimals, and we can't do this with negative numbers. It is only whole numbers. starting from 1 and up. There is something with 0 factorial, but we're not going to talk about that yet. It's generally positive whole numbers from 1 and up. Okay, factorial using Desmos. So to give you all an example, I'm going to type in 6 exclamation mark, and then there, it does the calculation. Now, if you can't find the exclamation mark for whatever reason on your keyboard, you can always go from here, from the keyboard at the bottom. It has something that you can pull up. It has other functions too. If you don't know how to do them through the keyboard commands, you can just click through there. But we want the exclamation mark. So we're going to go to ABC, and then we're going to go to exclamation right there. And there it is. Okay, so let's say I want to do 8 factorial. There, it calculates from 8 all the way down to 1 and gives me that answer. Okay, that's using the Desmos calculator. And then all the steps are right here on ClassKick if you have the ClassKick notes open. And again, the link to the Desmos calculator is linked in the notes too. So let's move on to TI-84. If you want to find factorial using the TI-84, we're going to first type in the number. So for example, we're going to type 10 factorial by doing the following. 10 math, and we're going to go all the way to the right to probability, which is labeled as PRB. And then we're going to type in the factorial, option 4, and then hit enter, and then it'll give you the answer to that, which is a large number, 362, I believe that's 3,628,800. And that's it. Okay. So you try number 2. I would like for y'all to, with whatever calculator you have, practice calculating factorials through y'all's calculator and then getting your answers. Entering your answers into these boxes. Check your answers by moving this box over here and just seeing if you did everything right. If you did everything right, it will actually tell you whether you did something right or wrong. And then if you just want to make sure you're right, move this box and you'll see those answers. Okay, so go ahead at this time, pause the video, try these problems on your own. Otherwise, I'm going to continue on and show y'all how to do this. Okay, I'm only going to show y'all one with both calculators, so I'm going to start with number 5, and then I'm going to show y'all the rest. So 5 factorial using the Desmos calculator, you're simply going to type 5 exclamation mark. And if you don't know where the exclamation mark is at, it's on the 1 button. So you're going to hold shift and then press 1. And then there it is. Or you can just click on the keyboard right here, go to ABC, and then find the exclamation point right there. Either way, the answer is 120, which again, it's counting 5 times 4 times 3 times 2 times 1. Just to show y'all, 5 times 4 times 3 times 2 times 1, which is 120. Exact same thing. Using the TI-84, we press the number first, which is 5. Then you're going to press math, go to the right to PRB, hit option 4 for the exclamation point, which is the factorial. Hit enter, and then done. 120, which again is 5 times 4 times 3 times 2 times 1. That's all 5 factorial means. Okay. So that one is 120. Then I'm going to show you all the rest. 3 factorial is 6. 9 factorial is 362,880. 12 factorial is 479,001,600. And then 7 factorial is 5,040. That's it for you try number 2. Moving on to the fundamental counting principle of addition. So, scenario 1, when you have 2 events and want to know the number of ways one or the other event occur. What this means is you have 2 things going on. So let's say you have somebody choosing 10 different flavors of ice cream. Then you have somebody choosing 1 marble from a bag of 12 different colored marbles. We want to know how many ways you can complete both events at the same time. How many ways can you choose an ice cream and pick a marble, basically? So, those 2 things are not related in any way. Picking ice cream and choosing a bag of marbles. So, to find out the many different ways of completing both events at the same time, we add the 2 events. So, 10 ice cream choices, 12 different marbles, you add them together and you get 22 different ways of completing the same thing, or at the same time. So, there is no way of completing both events at the same time. This is scenario 1, where you have 2 unrelated things. The number of ways to complete event A, or, and again, notice how I have or highlighted here, or event B is both event A and B, their values added together. So now to show you an example. Now I'm going to block some of these numbers and reveal them as we go. In this example, your local coffee show has a basket containing individual bagels for sale. The basket has 8 plain bagels. So again, it has 8 plain bagels and 6 sesame bagels. You decide to choose one of the bagels for breakfast. And how many ways can you choose either a plain bagel or a sesame bagel? Now notice how bagels are part of the problem. Notice how we have a plain bagel and we have a sesame bagel. The only relationship between them is that they're both bagels, but they have a different, they're made differently. One is just plain without anything on it, and the other is sesame with seeds on it. So the 2 do not have any overlap. Not in this sense anyways. Not in what we're looking for. How many ways you can choose either one plain bagel or a sesame bagel? So notice again the or statement. The or statement. That means we're going to add these 2 events. There's no way for completing both events at the same time because we're only choosing one. We're only choosing one of them. So, we're going to add the number of plain bagels, the number of sesame bagels, and figure out how many ways we can choose plain or sesame. Number of plain bagels is 8. Number of sesame bagels is 6. 8 plus 6 is 14. There's 14 different ways of choosing either one plain bagel or one sesame bagel. 14 is our final answer for this. Another example. In how many ways can Pedro draw a red or green marble from a jar containing 11 red marbles and 6 green marbles? Notice the problem here. It says either a red or a green marble. Okay? So we have 11 red and we have 6 green. Notice how the red and the green, they don't overlap each other. Their classifications don't overlap each other. And so there's no way to cut that there's any overlap between these 2 different types of marbles. Okay? So we're simply just going to add them. number red or number green, which is 11 plus 6. 11 plus 6, when you add them together, is 17. Okay, you try number 3. Jonathan has 5 PS4 games and 3 PS5 games. And how many ways can he choose a PS4 game or a PS5 game? So, figure that out. How many are PS4 and how many are PS5? Notice the or statement means there's no overlap. So, you're going to add the two individual things together. Okay, so follow the steps. Check your work behind this box. See if you did everything correctly. Pause the video and do this on your own. Otherwise, I'm going to continue on and show y'all how to do this. So again, Jonathan has 5 PS4 games and 3 PS5 games. PS4, PS5, just for argument's sake, there's no backwards compatibility. They're both games individual to its own system. So there's no way these things overlap. 5 plus 3 will give us the total different ways we can choose one game out of all of it. 5 plus 3 is 8. And there we go. That's it for you try number 3. So, scenario 2. We have another or statement, but you got to be careful with this one. I'm going to show you what's different between scenario 1 and scenario 2. So let's just read through this and then we'll go through an example. So, scenario 2. When you have 2 events and want to know the number of ways one or the other event occur. Again, notice how this is an or statement. So we know with or statements, we're going to add things together. But there is a caveat here. There are some ways of completing both events at the same time, meaning there's overlap to each other. So the number of ways to complete events, A or B, the formula is going to be modified just a little bit. Because again, think of this like as a Venn diagram. You have event 1, you have event 2. Event 1 has a certain amount of ways. Event 2 has a certain amount of ways. They both have an overlap because they have some similar characteristics that describes either one. So to make sure we don't count that overlap twice, we're going to subtract that middle part so that we only state it once and get how many total ways we can complete these events. So just to go back and show y'all the previous, again, with the previous scenario, there is no way of completing both events. So we just simply add them together. This new scenario is, well, now they have some overlap. So we need to take one of those away so that we don't explain it twice. We don't say it twice. So let me give you an example now to show you. Again, notice the or statement means we're going to add. So, example of scenario 2. A jar holds 8 large red marbles, 6 large blue marbles, 5 small red marbles, and 4 small blue marbles. Okay? In how many ways can we choose one blue marble or one large marble? So I want y'all to notice what I just underlined here. There's 2 different descriptors for marbles. Large red, large blue, small red, or small blue. Each one has 2 different things that explain that marble. So some are red and large, some are blue and large. We can imagine that there's going to be some overlap with some of those things. Okay, so things are going to be just a tiny bit more complicated. But here we go. Let's tackle the problem here. We want to figure out one blue marble or large marble. So we need to figure out how many total blue marbles we have, how many total large marbles we have, and then figure out what overlaps and take that out. So again, first thing we're going to do is figure out the amount of blue marbles that we have. So if I look at the problem, I'm going to erase some of these to kind of make sure it's not cluttered as we're talking about this. Blue marbles, let's look for all the blue marbles. So 8 large red, nothing there. 6 large blue, so we have 6 large blue marbles. And then we have 5 small red, and then we have 4 small blue marbles. Okay? So 6 plus 4, right now we have 10. We have 10 blue marbles. Now the number of large marbles, I'm going to use a different color for this. Let's say blue. Large marbles. So I have 8 large red marbles. Let me do that a little bit better. 8 large red marbles. I have 6 large blue marbles. 5 small red, and then 4 small blue. I don't care about those. So now let's look at the total of large marbles. So that would be 8 plus 6, which will be 14. Okay, now look at what I underlined, circled, and look what has been circled twice. Which number has been circled twice in us finding this? If you look carefully, number 6 has been circled twice. And then if you look right here in our math, you'll notice the 6 being repeated twice. Well, we don't have 2 sets of these. We only have 1 set. So we have to subtract one of those, because we don't want to count it twice in our calculations here. So that's why in our math you see the following: 10 blue marbles plus 14 large marbles. Take away the one that overlapped, one of those 6s that overlaps. Okay, so take that away, plug it into our calculator, and we get 18. So 10 plus 14 is 24. 24 minus 6 is 18. We have 18 total ways of getting one blue or one large. Okay? And again, we know we have to subtract because we notice there's overlap. Look at the descriptors. We have large red, large blue, small red, small blue. Some of those descriptors overlap with others. So we know we needed to subtract. Whereas in scenario 1, we only had one descriptor, plain and sesame. There's no overlap with those. So we didn't have to subtract anything. Whereas scenario 2, we do. Large red, large blue, small red, small blue. Okay, hopefully that makes sense. Okay, here's another example, just to make sure. The robotics team has 5 junior boys, 8 freshman boys, 3 junior girls, and 7 freshman girls. Again, notice the descriptors here. Junior boys, junior girls, freshman girls. You can tell that there's going to be some overlap here when discussing these numbers. In how many ways can one member of the club be chosen if the member must either be a junior or a girl? So we're looking for junior or girl. So the way we're going to do this is total up the number of juniors with the number of girls. We're going to take away the overlap that they have and then get our total answer. So first let's look for juniors. Okay, so we have 5 junior boys, 8 freshman boys, so that's not juniors. We then have 3 junior girls, and then 7 freshman girls. Okay, so that's all we have. For juniors, we have 5 plus 3, which is 8. So we have a total of 8 juniors. Now the number of girls. So for girls, we'll look at the descriptors again. 5 junior boys, no. 8 freshman boys, no. 3 junior girls. So we have 3 junior girls, and then we have 7 freshman girls. So 3 plus 7 should give us 10. Okay? We have 10 total girls that can be a part of this club. Now, if you go through the word problem, you can see we have some overlap here. We counted 3 twice, so we need to take that away. And again, if you go through the math the way that it's presented right here on the slides, you'll notice that 3 is represented twice. Well, we need to take one of those away. So we subtract one of those 3. We subtract one of those 3's. So now, our final answer, 8 plus 10 is 18 minus 3 gives me a total of 15. There are 15 different ways of choosing a member that is either a junior or a girl. That's it. Okay, you try number 4. Michael wants to buy a new car. The car dealership has 6 red new cars, 5 red used cars, 3 silver new cars, and then 7 silver used cars. In how many ways can Michael choose a car if he wants either a new car or a red car? So go through the work. I have it labeled right here, just like the previous problems. So answer each part and then get your final answer. Move the box right here to see if you're doing everything correctly. Otherwise, if you enter it and you get it wrong, it'll show you that you're wrong by coloring the box in red. If you're good, it'll give you a check mark and a green outline to it. Okay, but anyways, so go ahead and pause the video. Try this you try on your own. Otherwise, I'm going to continue on and show y'all how to do this. Okay, Michael wants to buy a new car. In how many ways can Michael choose a car if he wants either a new or a red car? And again, notice the or. And that's going to be important for when we get to the next type of scenario or next principle. Or means we're going to add things together. Okay, but when we add these things, we notice that there's going to be overlap based on the amount of descriptors each of these things have. So we want to figure out how many new cars there are from the information that's given to us. Excuse me. So we have 6 red new cars. So red new, we have 6 of them. 5 red used, that's not a new car. We have 3 silver new cars. So 3, and that's it. So 6 plus 3 means we have a total of 9 new cars. Excuse me. Now, red cars. Let's look for red. The car dealership has 6 red cars and 5 red used cars. The silver ones we don't care about, so we're not going to worry about that. But we have 6 red new and then 5 red used. 6 plus 5 is 11. I notice how I have the colors backwards in these boxes. That doesn't matter, just something I noticed. Now look at what we have that overlaps. 6 gets represented twice in either one. We need to take one of those away, so we need to subtract one of those 6's. Okay, and then we're going to get our final answer. 9 plus 11 is 20 minus 6 should be 14. And there we go. So 14 different ways of choosing either a new car or a red car. And that's it for you try number 4. Okay, going to a new fundamental counting principle. Fundamental counting principle of multiplication. The previous 2 scenarios were for addition. Scenario 1 meaning there was no overlap. Scenario 2 meaning there was some overlap. For multiplication, whenever you have 2 events and the outcome of one does not affect the outcome of the other. Okay? Number of ways you can complete event A and event B is M times B. Notice how we have and being said. And is an indicator that you're going to multiply the values instead of add them together. So here's an example of how this applies. Rhonda has 6 shirts. Let me use a different color. Has 6 t-shirts and 4 pairs of pants. How many different outfits can she make? Okay, so again, whenever you have 2 events and the outcome of one does not affect the outcome of the other. So the amount of t-shirts we have does not affect the amount of 4 pairs of pants that we have. One event does not affect the outcome of other. We're trying to find the different outfits. We're trying to put them together. So we need to multiply because there's just different combinations that we can deal with in terms of this example. Okay? So 6 t-shirts times 4 pairs of pants. There are 24 different outfits that we can have for Rhonda with these numbers. That's it. Simply multiply the 2. And again, notice the and. Well, no, don't notice the and in here. It's not explicit. So, yeah, that's it. That's all I'll say. 6 t-shirts, 4 pairs of pants. One does not affect the other, so you simply multiply them. You want to figure out different outfits to put together. You're not simply just choosing one of each. You're putting them together to make different outfits. So, multiplication. Here's another example, just to kind of drive the point home. Rachel is planning courses for next year. She can choose from 2 science classes and 4 math classes. In how many ways can she choose 1 science class and 1 math class? So again, notice the and in the problem here at the end. How many ways can she choose 1 science and 1 math class? So there's different combinations that you can have with this problem. Because of that, you multiply them instead of adding them together. You're not doing 1 science class or 4 math classes. You're choosing 1 science and 1 math class. And so there's different ways you can choose between the 4 math classes and the 2 science classes. And therefore, all you do is multiply the 2 values. 2 times 4 gives you 8 different ways of choosing classes for college. Or whatever it is. It doesn't say college, I just realized that, but whatever you're choosing the classes for. Okay, you try number 5. Pizza Pie Restaurant offers 2 kinds of crust, 4 sizes of pizza, and 12 toppings. How many different 1-topping pizzas are available to order? So, crust and sizes and toppings. This is an indicator, just like the previous ones. I kind of said not to worry about it, but I'm realizing now that it is one of the indicators. 2 science classes and 4 math classes. 6 t-shirts and 4 pairs of pants. 2 kinds of crust, 4 sizes of pizza, and 12 toppings. How many different one-topping pizzas are available to order? When you see the word "and," it means you're going to multiply those values. So, find each number, multiply them together, get your final answer. You can move the box right here to check and see if you did everything correctly. So, at this moment, I would like for y'all to pause the video and try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. So, we have 2 kinds of crust. So there's 2 ways of choosing crust. We have 4 sizes of pizza. So 2 kinds of crust, 4 sizes of pizza, and 12 toppings. So we're only choosing 12 toppings. We're only choosing 1 out of the 12, so that's why we just put 12 toppings there. Multiply all these together. 2 times 4 is 8. 8 times 12, I believe, is 84. Let me check. No, I'm sorry. 96. 8. That should be 96. I was off by 112. So 96 is your final answer. There's 96 different ways of ordering 1 topping pizza. Which doesn't seem like there is, but because you can choose multiple different ways, the sizes expand by a lot. And that's your final answer. Okay, that's it for 5.01 notes. If you have any questions, let me know. Here's my phone number and email. Text or call. Anytime after 5 p.m., though, I do tend to not answer because that is when I'm off of work. But if it is important, I'll try to answer it as soon as possible, okay? Otherwise, just send me an email, and I'll answer it from there, okay? So, that's it. Hope you have a good rest of your day. Take it easy, everybody.